be recapping some important theorems on Euclidean geometry which are important for paper 2. So now the first theorem which you might have heard, which is a grade 11 theorem, is a line from center, right? So this theorem is mostly there and it also has a proof. So to prove this formula, this theorem, feel free to go to my playlist on Euclidean geometry and you will see how to prove this theorem. So this theorem goes like this. Okay, so if we are given a circle with a chord is simply a line that joins two interior parts of circumference, but it doesn't pass through the center. And here we're going to have a line that will be perpendicular to this chord. So let's call our chord AB. So if this is the origin, is point O, and let's say here we've got point A. So let's say here we've got point A. This here was supposed to be point A. So let's quickly remove that. Okay. So this is supposed to be point A over here. Okay. So now, what does the theorem says? The theorem says that if a line O is coming from the center and it's going perpendicular to the chord AB, then this line OA will divide AB into equal halves. Meaning that I just put A twice. Let's say this here is C. This means that AC will be equal to BC, provided that OC is from the center and it's perpendicular to AB. The reverse is also true. The converse will say that if OC is from a center and it bisects AB, then this line is perpendicular to line AB. So this is the theorem 1. And the reverse is also true, right? So for the converse of this theorem, we're going to have a circle again. And then this time, we're going to have more or less the same. Let's say here we've got point X. And let's say here we've got Y. And let's say this midpoint here is Z and this is O. Okay. So what can we say about this theorem? If xz is equal to zy, what can we say? So let me just remove this. So if xz is equal to zy, what can we say? Well, before we said that if this angle here is 90 degrees, therefore these two lines are equal, right? Now what does it mean? If these two lines are equal, it means that this angle must be 90 degrees, right? So if we're in an exam and you're given a line that from the center, and that line bisects the chord, to bisect is to cut into equal halves. If it bisects the chord, therefore that line also makes a 90-degree angle. Okay. So more examples will follow on that. So this is how you can do this, and make sure you know how to prove these theorems. Okay. So let's have an example on how we can apply this. So suppose we are given a circle and we are given a chord and we've got a line here. Okay. So let's say this is A and this is C and this is O. Okay. Now if the radius of AO is 5 and let's say this is 5. Okay, let me fix that. If this here is 5 and let's say here we've got 4, calculate the length of AC. So now if this angle here is 90 degrees, calculate AC. What do we know about this theorem? Well, I can see that this line here is coming from the center, right? and it's going perpendicular to the chord AC. By definition, it means that AC, let's say this is D here, AD must be equal to DC, right? So if AD plus DC, AD plus DC, okay, sorry for that. So if AC plus DC is equal to AC, what does it mean? We are saying that AD is the same as DC, right? And we are required to solve for AC. So now what we're going to do is we're going to make use of this triangle over here. It's a right angle triangle, right? This is also 90 degrees because of sum of angles on a straight line. So if I take this triangle here and I put it here, I've got a 5 here, I've got a 4 here, and I have to solve for x. So I can solve for x using the Pythagoras theorem. This says that 5 squared, which is the hypotenuse, is equal to x squared plus 4 squared. 5 squared is 25 minus 16 is equal to x squared. 25 minus 16 is 9, so 9 is equal to x squared, and it means that x is equal to 3. So this means that this length here is 3. That is for AD, right? And we're looking for AC, which is the whole of this length, right? We're looking for the whole of this. But because we have found the AD, we can say that AD is equal to 3, and we know that AD is equal to DC, right? When you state that AD is equal to DC, you must give a reason, right? Plus 3, then it's equal to AC. Then from there you can say that AC is equal to 6. So now here, you were supposed to start by saying, okay, AD here is equal to DC. And what will be your reason for that? The reason will be line from center. So this will be line from center perpendicular to chord. Okay, so they know that line from center perpendicular to chord will bisect the chord. So by writing this reason, then you are good to go. So that is for the first theorem, and make sure you know how to use it. One thing that is also important about this one is the fact that let me use a different color for that. This radius AO is the same as the radius OC. Okay, radius of a circle are equal, and the reason is radii. So whenever you use this reason that if they say what is OC, OC is also 5. Why? Because of radii of a circle. Then you're good to go. That's all for the first theorem. Now let's look at this different theorem. So now we've got a theorem, a line at the center, an angle at the center. Okay, if I'm given a triangle here, something like a triangle, and I'm given another one here. This angle here is twice this angle. So if this angle here is 30 degrees, this one must be 60. Okay, and whenever you use a reason for this, you must say angle at the center theorem. Then you're done. Okay, so these are angles at the center theorem. So make sure you know how to use this theorem. Whenever you see a shape like this, just know that I must start at the same place and then end at the same. I must start on this side and then on this side, and then I must end on the same place on the circumference. Then that's when we have angles in the same and angles that are at the center theorem. It can come in a different way. This theorem, it can come like this. So it's also true, but this point must be on the circumference. It mustn't go out. Okay, this here is at the center and this is at the circumference, right? So if angle A is equal to 20 degrees, then angle O must be twice of it. It must be 40 degrees. This is angle at the center theorem as well. So it can come in two ways. Okay, there's also a theorem that is mostly similar to this one that most learners confuse, but we'll also cover it in next minute. So this here are the angles at the center theorem. So make sure you're able to use them. Whenever you see an angle at the center, and one is at the circumference, make sure that you end in the same place, and then that angle that is subtended must be half of the angle that is at the center. Now let's look at the angles in the same segment. Segment, right? So if these angles are like this, these angles are in the same segment, right? They are subtended by the same arc, okay? So an arch is this over here. They are subtended by the same arc. Well, if that's the case, then we are allowed to say that if this angle here is x, this one here must also be x. As long as they form a butterfly, okay, or a bow tie, however you want to call it. So these angles here, which forms a bow tie, are equal. Same applies to this one over here. This one is also equal to this one. Okay, so make sure you know how to use this theorem. And again, you can also have a third one like this. Well, it's still in the same arc, right? And this angle here is also x. Okay, and that's how we can do this. So make sure you know how to use this rule. Okay, so this is the angle in the same segment theorem. Now there's something again about angles in the same segment, but this time it comes differently. What if they're not from the same segment but they're from the same chord? So there's a rule that says equal chords subtend equal angles, even though they are not on the same place. So let's say I've got a situation like this, and I've got another chord, and that looks like this. Okay, let's put that there, and then let's complete this triangle here. So if this line here is equal to this line, okay, if these two chords are equal, the angles they subtend are also equal. So it means that this angle will be equal to this angle. So equal chords subtend equal angles on the circumference of a circle. Okay, so make sure you know how to use this rule. So if I'm given A here and I'm given B here, and I'm told that okay, the length of this is 5 meters and here is 5 meters, and they tell you that okay, angle A is 30 degrees, and they say to you, what is angle B? Automatically you must see that okay, no, angle B must also be 30 degrees. Why? Because of angles that are subtended by the same chord. Okay, so equal chord, okay, let's say same chord, they're the same, but then yeah, they might be on different areas, but then as long as they are within the segment, then it holds. Okay, so these are equal chords subtend equal angles. And then let's talk about the tan chord theorem. So the tan chord theorem, it's mostly there, okay, and also its proof is also examinable. So it's very important for you to know how to prove this theorem. And feel free to check my video, my playlist on Euclidean geometry, on how to prove the tan chord theorem. So it looks like this. Okay, the triangle within a circle, and there's a tangent here. So this angle here is the same as this angle here. Okay, as long as this line is a tangent, so this line must touch the circle only once. Okay, it mustn't cut, but it must touch the circle only once, and then this angle here will be equal to, if this is 30 degrees, this will also be equal to 30 degrees. Okay, and the reason for that is tan chord theorem. Just write tan chord theorem and you're good to go. More examples on how to apply these theorems are there on my channel. So this lesson is just to remind you of some important theorems which you must know for exam purpose. So with this, you must be able to know the tan chord theorem. So what about this one? A tangent and a radius. So if I'm given a tangent and I'm given a radius, this makes an angle of 90 degrees. Okay, so always must know that a radius is perpendicular to a tangent, and this is a theorem. Okay, you must know that if I'm given a radius here and I'm given a tangent here, then automatically you must know that the angle here formed will be 90 degrees. Okay, so I hope that makes sense. And more lessons will come on how to apply the other theorems like the probe theorem, similarity, midpoint theorem, and so on. So I hope this video helped anyone. So share with your friends and like, comment, subscribe, and feel free to ask in the comment section and I will reply. Thank you for watching.